In lesson 3, guys, we're going to be talking about the group names of the different elements. We'll be talking about what is IUPAC, and we'll be going over those different elemental groups.
Okay, so everything we teach you in chemistry has been approved by the IUPAC, which is the International Union of Pure and Applied Chemistry. It is an organization that sets the standards for our chemistry class and chemistry in the world. The elements can be grouped into 3 main groups in the periodic table. So we have metals, metalloids, and nonmetals, which we discussed in the last video. Across the periodic table, from left to right, the properties of the elements become less metallic and more non-metallic.
This is why, for example, francium on the far left-hand side is the most metallic, and as you go to the right, fluorine is the most non-metallic. So in our very first group on the periodic table, which is lithium, sodium, potassium, rubidium, cesium, and francium, they all have 1 valence electron. That means they form cations with a positive 1 charge. They're also incredibly reactive in water, which means that as you go down the list, francium is going to be the most reactive metal. If we had a sample of francium that was large enough and you threw it into the ocean, you would get something like an atomic blast result. However, since these guys are so reactive, they are only found naturally in compounds. If you have a pure potassium or rubidium sample, it would immediately explode or react violently with water. So this is what the different elements look like: lithium, sodium, potassium, rubidium, cesium, and francium. But francium is in a compound, so that's why it looks like that reddish rock. Also, francium is incredibly radioactive.
Notice that some of them are also in containers. The only way to contain them so they don't react with the environment around them is to keep them under oil. Group 2 is the alkaline earth metals. In the last video we said they're a little less reactive than group 1, but they almost mimic group 1. That's why they have a similar group name. They have 2 valence electrons, which means they form positive 2 cations, losing 2 electrons. And they're fairly reactive in water, just like group 1, but just a little less reactive. And then they're only found naturally in compounds, and they're called alkaline earth because we find most of them in the Earth's crust.
Yep, and also you can find a lot of these in our bodies. Like magnesium is found commonly in plants, but calcium is found commonly in our bones.
Here are some of the examples of what they look like in real life. Now, radium does not come in clock form. It's that glowing color that you see on the clocks, and it is very radioactive.
Now, group 3 to 12 is going to be what we call the transition metals. Now, the transition metals, they all have different numbers of valence electrons, and you can determine that by looking at the last number of the electron configuration. So they're going to be generally non-reactive metals. That means they don't explode in water. They're either found in compounds or in a pure form. And when they are in a solution, an aqueous liquid solution, that solution is going to be colorful.
Also, because this is the D block section, they can lose more than just their valence electrons, which is why they have more than just 1 positive charge. So if you look at Mn, which is number 25, you'll see that it has 4 different positive charges.
So looking at these different examples, you have scandium, chromium, iron, nickel, copper, yttrium, niobium, myodinium, platinum, silver, lanthanum, tungsten, iridium, gold, and mercury. And when you put these into solutions, you're going to get different colors. That's the reason why blood will always be red, because it has iron in a liquid solution. Cobalt can be either pink or blue, depending on the concentration of the cobalt ions in the solution. And nickel is going to be a greenish color.
And fun fact, this is how they used to make paints back in ancient days. They used to take those metals, mix them up, and use those colors to paint with.
Yeah, ask your parents. They should probably know all about that stuff. Ancient days.
Ancient days. Group 17 are the halogens. They have 7 valence electrons. And like group 1, they are extremely reactive elements. They are going to form -1 ions, however. So fluorine and chlorine are the gases in the group. Bromine is a liquid. And iodine is the only solid in that group. You have to know that. We also know that fluorine is the most reactive of all of these halogen elements. Okay, so fluorine and chlorine are both colorless gases. Bromine is a red liquid that gives off this reddish, orangey, yellow hue. Iodine is a purple solid that immediately sublimes. And acetylene, which is the bottom of the group, is a radioactive substance.
Group 18 is going to be our noble gases. Everything in group 18, with the exception of helium, has 8 valence electrons. But everyone in group 18 is a non-reactive element. They all have a stable octet of 8 valence electrons. However, helium is the only one that is stable with 2 valence electrons. You need to know that. So it's very hard to see gases because they're all colorless, but if you were to excite them using excited to ground states, you can get different energy colors. So helium is a pinkish, neon's that red, argon, krypton, and xenon are different shades of blue. Radon, though a gas, is commonly found in a compound, but again, this is a very radioactive substance.
Noble gases are non-reactive because they have a stable electron configuration.
Now, hydrogen is technically not part of any group. It is found in group 1, and it's a gas at STP. Because of the fact it only has 1 proton, 1 electron, we have to put it into the group 1 category to follow the rest of the periodic trends.